Okay, let's work through this graph of y equals sine of x. Let's start by finding the midline. So I'm going to highlight the line that goes through the middle of my graph, and that's right here. Now, the equation of that line is what I'm interested in. So the equation of the midline is the line y equals 0. All right, next up, I want to find, I think the amplitude is the next easiest thing to find. So I'm looking at how far is the highest point from the midline. So we're looking at how far, let me use a different highest point here. How far does the highest point go above the midline? And if you look here, that is at y equal, or at when the y coordinate is 1. So our amplitude is just 1. And then the period of the function, remember I asked you on the graph to mark the beginning of the period with a green dot. So I'm going to always start at 0, 0, and then mark the end of the period with a red dot. So you may have to maybe trace through this to really figure out where the end of the period is. So remember, our period has to start and end at the same place. That completes one cycle. So we start at 0, 0, and we're headed up. We go down through 0, or through the x-axis again, but then we have to go back up to the x-axis. So it ends at 2 pi. So this distance is 2 pi. That is the length of the period. And then to figure out our intercepts are 0, 0, pi 0, and we could even go so far as to then say 2 pi 0. And what I notice is that each of these are pi units apart. So what I wanted you to try to do is write an expression for all of the different x-intercepts. So what we would do is we would say, okay, starting at 0 and adding pi is going to get us at least one of our intercepts. We could also say adding or subtracting pi would give us 2 of our intercepts. But what I want to do there is add in an integer, we'll call it n. So basically what I'm saying is if we multiply pi by anything and add it to 0, we're going to get one of our intercepts. And that's really the important thing here. And then finally, our y-intercept is right here at 0, 0.